I'm Claudio. I'm working for AirHelp as Senior Product Manager for the automation initiatives. So everything related to making the processes, internal processes from the company being automated by use of machine learning and even smaller rules-based systems and so on. So as presented already, I have more than 10 years in software industry. I was really a little kid when I started, and I started when at the time I support decisions, support systems. Decisions were the mainstream, and we're just changing the name for machine learning now. So I worked with distributed computing, machine learning in large scale, for e-commerce, for research, and so on. Just to present quickly what is AirHelp. So we help passengers to get their claims from flight delays and cancellations. And so basically, if you have delayed, if you have cancellations of your flight, you can, we support you to get the money that you deserve as a compensation. So, and what is basically machine learning? This is Elon Musk is trying, or probably saying that machine learning will be the deadly thing for us in the next years. But we still have lots of humans to compete. And by definition, the formal definition of machine learning is a computer based on specific experiences, choosing a specific task and being measured by a specific performance measures, it learns with, based on this whole flow back. An easy way to turn these translations into these things is experience is what we are having as data. So all the feature vectors, all the data that you collect from all your data sources. The tasks is the supervised or unsupervised learning, and semi-supervised and semi-unsupervised things that appear now. And the performances is how you measure the accuracy of the models that are being created. So these three things combined, it's basically what machine learning is. Easier definition for that is that instead of writing code, you pass something into a black box, this data in the black box, and you have all the things prepared for you, like magic. So to start building products, the first thing that you need to know, or the basic things that you need to know, is calculus, linear algebra, statistics, and for sure programming, so you can make the things visible to our customers. But if you're doing, or if you're working for Tesla and so on, you should know a lot of these things because you're doing cutting edge innovation on products that are running there, and they are just like not using common ad hoc solutions. So you should really know a lot. And for building products, I need to be closer to here. For building products, you really need to know less than that. Machine learning, you just need to know the basics for the calculus to get an intuition. If you're using machine learning on your products, you just need calculus for getting intuition, linear algebra for the intuition and know why you're collecting the data and how you need to represent into vectors. Any statistics to know how to measure your data, how to understand how your data is behaving from the selections that you got. So, all my life into this machine learning industry, we have always the three actors. The first actor is the business, where they say, hey, I want to use machine learning now because it's cool and it's hype. Take all the developers, send to conferences, they will learn everything, they will come back, they'll sit for 2 weeks, and let's do a spike or a sprint, and we have our final solutions. And we are using machine learning. We update the blog, we update the page, we buy a domain called mycompany.ai, and it's awesome. The engineers, on the other hand, they will say like, well, I'm listening a lot about it, and everybody's doing this thing called machine learning. I want to do that too. But when they start doing the thing, they say, well, what's actually a vector? Vector is just a class that I can use. It's just like an array. What is actually what I'm doing here? And the operations that you do for multiplication and so on, and we still have like 2 for loops to calculate multiplications into matrices. So engineers are stuck based on, like, they don't know what machine learning or data science and all that stuff is talking about. And the data scientists in the end, the statistics guys that did mathematics, that they did this whole thing and say like, well, I know by heart all the derivatives, I'm awesome, I know how to do linear regression by heart. And they sit there and they say, well, it runs on my machine, my model, but I can't deploy that. I don't know what is AWS. I don't know what these guys are talking about. What the business wants, he just wanted the model, it's here. I have this Python or R script, and I can predict anything that you wish. So these are the 3 main things, and one of the biggest, that's why I moved actually to product, because I wanted to make sure that we could combine these whole 3 words, where we can explain to the business what they need to be cautious about, that machine learning and all that stuff, they cost something for the business too, that the engineers need to be aware and where to find the sources, and the data scientists how to learn to be a software engineer. This pyramid is basically how I follow on any product related to machine learning that I handle in the company. And it's really starting from the bottom. So you can see like the collection, the moving and storing, the exploration and transformation of your data, aggregation, and learn and how to optimize that. These words, they are quite similar for any kind of stuff. Even if you take agile development is, you do something, you learn from what you did, you iterate from your learnings, and you do it again and again and again. So the first thing that you need to do as a product manager or anybody involved on the decisions of having machine learning in a company is to have a data collection as a culture. You can't have any kind of database solutions if you don't know how to do data collection. This meaning logs, this is meaning different data sources, different databases, different systems that your company has. Probably the finance department has one specific tool for themselves. Some others are still probably using Access. Lots of others are putting their data on AWS, and there's no way to consume this data in an easy manner. So the first thing is to make sure that the company knows and wants to collect the data, and everybody has access to the data in a unified way. So either through API, either through a combined or a well-communicated source of collection. And I heard also, I mean, I hear every time, machine learning, if you input trash, you have trash in the other side. So this happens a lot also. This is really like a corporate thing where your boss asks like, hey, can you give me these reports? Can you give me the results of this model? And in the end, you're even not sure if the thing is correct. Or sometimes you're sure that the thing is not correct, but you just don't mention that out loud. After you have the data collection, you know where to go get the data. The second main point is create pipelines. Creating pipelines is not just machine learning pipelines as we see, feature transformation, selecting the models and so on, but this is ETL, old ETL things. How can you prepare your data that in the end you can use in a problem or in a task that you decide? If it's a regression problem, if it's a classification problem, if it's a clustering problem, and your data needs to be cleaned in a way, like data typed way, it needs to be cleaned and stored in an easy manner. So anyone in the company that has the knowledge or wants to do something with that data, it's already well prepared. So model pipelines, it's really, really, really important that it's inside of the culture of the company. As I said in the previous time, data cleaning is the most important thing that happens in machine learning. After you put anything into production, this is the 80% of the time that you'll be doing. And one thing that the business departments are not understanding, our bosses, they don't understand, is that data cleaning, they cost. They cost because data cleaning means you need to have a tool that you need to look to the data that you get in the models or like the things that you're collecting during your time in an easy manner. So either the users give the feedback or you can analyze the things that are happening. Google does that with us every day. So basically in the CAPTCHAs, they are sending all the data that were in doubt for their classifiers, and it says like, humans, clean the data for me. And I usually used approaches like, we take our data, even though that the model itself was built using like a neural network and so on. Usually I just take an SVM, which is like a, let's say, shallow machine learning solution, which was the state of art before. And I say like, give me all the data points that are close to the hyperplane. So this main line, the main line that cuts the space, give me all the data points that are close to that. Lots of companies, they do, hey, give me all the false positive and false negative and clean from that. But usually the false positive and false negative, they are really far from the hyperplanes because probably they're just noises. So there's some clever and easy way to say, give me all the things that are inside of the boundaries of the cluster. Give me everything that's close to the hyperplane. And then fixing the data iteratively and retraining your models, checking the data constantly that you receive from your performance, you can see the value out of that. We just saw in the Bluemix presentation that the models were retrained every time, but on this retraining over the time, something is happening to the data and it won't magically clean by itself. Models will just like get better because probably some stuff is happening that by luck made it better. And always think about generating data into logs, generating data on your sources, thinking on models. It's really like, okay. It's really like everything that you have needs to be already predefined in a way that you already expect what the business will request. So if you know that you are working with users on e-commerce, you know that people are selecting lots of products. They can be using, they can be color preferences, areas that they live, and so on, kinds of IP that you can track your user segmentation. So think about if marketing comes and tell me, I wanted to create like a Facebook campaign and I need to know which are the target groups that I need to set up in my campaign. If you would have this question, what kind of data will you use for getting this answer? So take probably the vision of the company, take the values of your specific department or missions of your specific department and think that the data needs to represent that specific goal. By having this mindset, you know that, well, most likely I will need to do segmentation by location, so IP is quite important. Probably if they are paying with like specific, if they need to do an account, add the city information and put that in a table where it's reachable and you can create feature vectors quite easily. Which is another thing. Data are highly distributed and nobody knows where to find sometimes. Old approaches don't hurt. I see many people really frightened, not frightened, but really excited with deep learning, which I love, by the way. It's don't miss that decision trees are still there. Don't forget the regular linear regressions are still there. Probably they are not the best or the state of art, but sometimes they are cheaper and they come in any kind of APIs that you can quickly prototype your problem. So we know, I mean, I'm in a product side now, we need sometimes to test one MVP. I don't need to be the state of art of image classification. I just need to know that is the user seeing everything that I expected to see? If yes, I can do A/B test, validate my assumptions, and then I'll just do another iteration with my team to make sure that the accuracy is better and the product gets better for the output that I deserve for the product. New approaches are great, as I said. One of the biggest things from deep learning is for unstructured data, for a long time, it was really hard to get better data representation. For text, we had lots of problems to maintain the context from the sentences. Even e-commercers, like the big e-commerce ones that also provide cloud solutions, they still use some shallow algorithms for like bag of words. They just count how many words are happening there, and they create classifiers on top of that. Sometimes you need context. Sometimes you need to say, I need to classify all the tweeters from a specific political campaign in a specific country, and you need to know, not just count the words, but you need to get the context of that. And a new approach, word embeddings, it's a quite old approach, but now you can solve the problem using word2vec, which is based on neural networks. So neural networks are great, and they are really the thing to be done. But don't forget the old approaches for product development can still be the biggest helper on your MVP. And deep learning is like this. You really don't need to be the master of derivatives to work with deep learning. We have lots of APIs that helps you to say to work with images out of the box quite easily. We have lots of support from the community. If you take TensorFlow, Keras, you have Slack groups for that, and you say like, I have this doubt, everybody's supporting you. And as a developer, we have Stack Overflow. So use deep learning for unstructured data. If you need to maintain context, if you're working with images, if you're working with sound, don't mess up with your mind using old approaches, because these are the cases that you need to handicraft features. You need to think on how your data pipelines need to look like, and it's much harder. But if you're just thinking about sometimes about text, and you need to test something quickly, old approaches can beat them. And also, a comment in here, deep learning can be costly. If you need to have some servers running your specific model, some of the models, if you need to load everything into memory for 10 hours to train, it's so GPUs can be really, reduce the amount of computation time that you need, but it comes with a price. But everything should be on the cloud, just telling you that the decision can be quite costly for you. Okay? Always measure your models. And this is always, every time that you do any kind of product that's based on machine learning, do reiterations and iterations again of the reiterations to verify if your model is still compatible from what the things that you're doing. Okay? So if your boss wants to run a KPI, say like, oh, how can I know that my thing is working? Use F-scores, use precision, use recall, explain the company what this represents. We know that what is a return on investment as a KPI, we know year-over-year costs and so on. If you have a company that's trying to use machine learning, the metrics that you measure your models needs to be passed to your business. So the CEO of your company needs to know what F-score means. He needs to know what precision means, because this will be your solely way to verify that at least the engineering part works. On the product side, we do A/B test. We see if the people are behaving well with the output of the model. Then it's another KPI. It's a KPI that they already know. But to measure your teams, to measure your data teams, always measure your models. Take it as a thing to your business and make sure that everybody knows what they mean. And everybody is on that. Lots of people, they say like, yeah, but I see lots of classifiers, logistic regression, SVMs, convolutional neural networks. I don't know which one is the best for me. And the software engineer guy, he doesn't know well what is a data distribution. Oh, it's a linear distribution in your data, or what? So if you don't know, iterate over everything on the first time. You have today Jupyter that you can quickly prototype your things. And I put this as an example because I have a list. These classifiers, actually, it's a set of classifiers. Actually, are all of the classifiers that sklearn is providing. And I'm classifying the infamous IRIS dataset for the flowers. I do cross-validation. I do everything like as usual. But the main part here is I've got to know that for the problem that I'm tackling here, decision tree classifier is the best classifier to work on the data that I have. So always use different models for your data and try them all, because if you don't know the distribution, this will be the best hint that you get to select the first to go further. On previous experiences too, we were running on top of Hadoop, so we have lots of queuing to select the models, and it was an e-commerce platform. And in e-commerce platform, we had the hierarchy of the categories of the clothing, of the fashion industry. So all the shoes, Pipto pump ballerina with laces. And all these things are under the same tree of the category. And we know that for each of the things, we needed to have one classifier. The second thing on top of that, not all the stores have Pipto pump ballerinas with laces for adventure weekends. And we have this thing on our tag structure. So this means also that since lots of shops have this kind of information, we won't have data to train a good classifier. So we wouldn't have to put SVMs there as like a default classifier, because SVM doesn't behave really well with lots of data, and it doesn't really behave really well with few data. So it behaves well, but even on this case, the SVM has a 95 F-score. So what we were doing is all the tags that we had in this category structure, we were testing 5 different classifiers, and each classifier had a specific approach also for the feature selection. So one of the classifier was word2vec for the feature extraction, combined with k-nearest neighbor. And we had the same for SVM, we had the same for convolutional neural networks when we were doing image. So we just did this combination. We took the tree, we put the tree as like a queuing. Everything that the parent had goes to the child as an input data for the training sets. And then we had the whole tree categorizing around 150 million products per day and we were retraining all the models, and all the models were retrained every 3 days. So we had always fresh data. On the same side of that, we had a department doing the cleaning for us. So usually the companies from e-commerce, they have people saying like, this is not a shoe, this is a shoe, writing rule-based system things that say if you find shoe in the name, then it's a shoe. We built a tool so that people could do the cleanup for themselves. Like they had like just the views, they right-click as a positive sample, left-click is a negative sample, and we didn't care. I mean, what's the classifier enabled there? Just say, show to the users of our systems the data that's representing two things. First, we wanted to solve is, let's show the things closer to the hyperplane so the classifier next time gets better data. And the second thing is, we know that there are some other data around that they were not marked as positive or negative sample. So can we do like a nearest neighbor thing on these other samples close to the samples that are in the hyperplane and say like, generate more data to us because we know that you're really close to this thing. We use edge maps from the image to do similarity. So we say like, just take everything that's close to the next positive sample that you got, resort the potential samples that are close to the thing that we provided. So then, if the cleaning before was being done, we were showing the things based on the classifiers that we got. We could do this thing and train all the classifiers every time. And by luck, tomorrow the SVM is the winner of this same on the same approach, product-wise. So focus on business goals. Machine learning is not just like taking the data and say like, hey, we have this stamp because we have machine learning. It's really focus on the business goals. Also from another experience, we were working on nudity detection, I would call it this, because we wanted to clean the page of if it's appearing any kind of nudity or sensitive stuff, remove automatically from the platform. We had 150 million items working. It's possible for humans to find out this kind of information. So we said like, yeah, let's train a model for finding nudity and send to our mails the results. No, but send this information for the cleaning so we can optimize the model. And the company was in 16 other countries, and we discovered that for France, it was perfect, like appearing nipples under an underwear was fine. You can't show the nipple, but if it's like a transparent underwear on top, it's totally fine. But if you're going to Asia, this is totally forbidden. This is really like harmful for our business. We couldn't have this kind of data there. But our models were correct. The models were having F-scores of 95. We could find everything that was bad. So we said, we can't use the same model for everyone. We need to change the model to be country-specific because the concept of nudity is different. I'm just telling you this example because then it's a case where the F-scores are not enough. Your model is perfect, but if you're not solving the problem of the business, then it doesn't matter. It's just like a good KPI, but it doesn't solve the problem of the company. And again, if you have a culture that you collect data to solve the problem of the company or your department, and you focus on the business goals, you understand that, and you iterate quickly, you do A/B tests, you know how to clean your data, then even the solutions after that are easier. We, 2 days, could say like, just split the models between countries. Everybody that's cleaning the data for France, everybody that's cleaning the data for Asian market, then we're okay for us. Okay? So focus on business goals, otherwise it won't be hard for long. So then going back to the pyramid,
It's basically what I've just said. When you're doing collection, look for instrumentation of your code. Sometimes you do like code generation. Logins, all the sensors. If you have a factory, if you have like autonomous cars, if you have external data coming from different partners, so if you're working on data integration for other customers, is there a way to collect that from an Ethernet? You need to store and move data easily. Everybody should be able to access this data. You need to have reliable data flow, infrastructure, you need to have pipelines, ETL, how to keep data that is structured and unstructured related to the data storage. Things that you want to maintain in memory, like just maintaining memory for like Redis and so on. Things that you need to keep for 2 years because it's a document from your legal department, and so on. So you need to explore and transform the data. So do always the cleaning. Build tools for yourself to do the cleaning of the data. Otherwise, cleaning will be a pain, and it will be really a pain. And that's a lot.
Do anomaly detection. Try to find the things that are happening to your data that can give you some insights. Outliers, they are not necessarily outliers for the business. Outliers can be a new opportunity for building a new classifier that gets that specific kind of data. Okay? Aggregate that, so use analytics, post this information somewhere that everybody can have access to that. Your data scientists, your engineers, your product managers, your directors, vice presidents, whatever your company structure has, work on the features, work on the training data. Training data is not, training data is volatile. If your processes in your company are changing, your classifier will start doing the bad decision because your model is quite old. So training data changes, and training data needs to be from the previous side also cleaned. Learn and optimize, do A/B tests, do experimentations, and use simple machine learning algorithms before. And once you have everything is prepared, then you say, hey boss, can we have 2 weeks of sprint just to do some cooler stuff with LSTMs, because it's the state of art. So yeah, so you've got the data, you have time to try out. After that, you have success. So everybody will be happy, and it's really good to be happy. The business are happening like this now. Lots of companies, they say like, I do AI, and internally it's just a bunch of ifs. So every time that you see someone just selling machine learning to you, the first thing that you should ask actually is, so do you know how your models are behaving? Are you measuring your precision and recall every time? How do you do the cleaning? Which are the tools that you're using to have your customers giving feedback for you? If you ask for Google, Google will say like, oh, we use CAPTCHA to clean the data. If some other companies, they use Amazon Mechanical Turk to send their data, and they'll clean that for like quite cheap service. So really, really be careful with that. And if you have a product and you want to be this business guy and you want to start doing the things with machine learning, the first toy project that you can take is go to the engineers and say like, what's the code that has the most amount of ifs, and you're quite tired of changing the threshold because the business wants to change their process. Many times it's like, hey, you know, when you have 20 customers and it's raining and the temperature is 38, the Facebook campaigns should be behaving like this. Developer goes to the desk, tries to find the if, adjust the number that's hard-coded. Sometimes you put outside in a class to be beautiful, but it's hard-coded. Somebody needs to change that. If you have lots of situations like that, That's the best opportunity to have machine learning there. Find out and kill all the ifs. If you find if, it could be killed, and quickly. Another problem with that too, actually, is, and it happens to the business. So we're using some specific models. The business will come to you and say, well, so if you're removing this bunch of ifs and the precision of our service is getting better, we know that machine learning doesn't complete all the data. You can either say, we have a good precision, but the recall is really low, so we just do a coverage of 30% of the actions that we need to take. So the business will ask you, and you hear that many times, say like, oh yeah, Claudio, so you're telling me that this classifier thing is working better, but it doesn't do so much coverage. Can you tell me which are the ifs that the code is generating so we can train the people in our department? I was like, I can't. I don't know. It's a black box. How come? You give me a KPI, you do a black box, and you don't know how can I reproduce with humans? And use decision trees, because decision trees can give you at least a good excuse for the business. It's the first strip, like I was always giving you the wrong data. So use the opportunity to take these ifs, but you will hear down the way that the business will want to know why these ifs are being removed and what's the meaning of that for making sure that the humans can act the same way, okay? So just to wrap up, the takeaways that you need to get is every time that you're doing collection of features, labels, outputs, expected outputs for your business, you're doing the experience part. If you know how to decide how to use the data that you get, either supervised or unsupervised, these are the tasks that you're doing, and you're marking another check on your business for machine learning. And if your KPIs are F-score, precision, recall, are they under curve, and so on, then you have the third mark on your thing, and you have the label of your company that you're doing machine learning. And you can buy a domain with .ai. Plan, do, act, check. This is a thing happening in the industry for many times. Any process, Toyota, and all these things related to process and product management, it's always mentioning the PDCA cycle. Plan, do, act, check. You need to plan how their data structure needs to be. You need to do something that you can iterate over and measure that. You act by doing the shipping to your customers, and you check the results, either A/B test or internal results for your models. You can't say that you can start. We are having this kind of conferences now more and more, and it's great. The community is great, and we have lots of engineers that they want to talk to data scientists, business guys coming and trying to learn, because at the time that they started working, the most cooler thing that was happening was Corba. And you have lots of things to try. You have Keras, you have TensorFlow, you have Pandas, Spark, Flink, everything. So more to come. You can learn that, and learning is quite quickly. So use Coursera, Udacity, Stack Overflow, the best source, and lots of meetups. We just have the community that we have now because we have people interested in learning, and we have people interested in talking. So if you want to increase the data science community here, mainly in Gdansk for you, most of you, so create your own meetups, create your own study groups, take one book, sit with everyone and discuss the chapter and try to toy around with the chapter. Do like a beer and pizza to watch Andrew and G together, and you watch the Coursera course, you drink, you take a pizza, and you discuss with that. It's the best. And talking about machine learning and drinking, the GANs, the generative adversarial networks, were created in a bar. So if you go to the bar, talk about neural networks, because it can be the next step on your lives. And that's all. So thanks a lot. If you have any questions, just let me know.
Thank you very much.